Okay, so welcome to the minerals part of the chapter. This is Mrs. Frobel. I'm going to be talking about minerals, their formation, their classification. So we're going to use all the information that we gained from the basics of chemistry when we talked about elements, and we're going to apply that to the minerals. Now, while you're watching this presentation, I'm going to ask you 3 questions. You're going to write down the answers for them, and you're going to submit them using the markupsync.com email address. So you probably want to put that in Notability. But for now, I would get a piece of paper out and write down the answers to the questions that I ask you. And then after this presentation, I'll have you do a Socrative review so you can apply what you've learned. So the first part of this chapter, we're going to talk about how do minerals form, because you need to understand why minerals are located in the places that they are. There are certain environmental concerns that we have to look at. And then we want to look at how minerals are classified. So we practiced this in lab the other day, looking at hardness, color, streak, so we could group the minerals according to their properties. Okay. In this section, we're looking at the definition of a mineral, and what I would recommend is maybe make yourself flashcards. So you're going to have to determine mineral based on a certain criteria, and the criteria is first, it's naturally occurring. So when we say that something is naturally occurring, that means it's not lab-made. You like my lovely scrawl here? That's supposed to be an E. I don't know why it does that to me. Okay, it has to be a solid substance. So that means that you can't have a liquid or a gas as a mineral. It has to have an orderly crystalline structure. So what that means is, for instance, we talked about salt. Salt has a regular repeating pattern of sodium and chlorine, and it alternates. And that repeating pattern actually forms the structure for the crystal. And we'll talk more specifically about that when we talk about certain minerals. It has to have a definite chemical composition. So what that means is, for instance, water, which is not a mineral, it has 2 hydrogens for every oxygen. So you're going to find certain minerals have a certain number of atoms of each type, which gives them that composition. And then we need to know that they're mostly not carbon-based. Sorry, I don't know why my pen is doing what it's doing. But they're not carbon-based. Oh, that looks terrible. I apologize. I guess I can't write on the bottom of this slide. But I would definitely write down the fact that inorganic means it's not carbon. Okay, now we want to talk about the formation of minerals. So there's actually certain pathways for minerals to form. The first type is crystallization from magma. This is my first question. So what I want you to tell me is what type of mineral is crystallized from magma. Magma is lava found underground, and obviously it's hot molten rock, and as it cools, it actually allows crystals to form, and those crystals combine to form minerals. So your first question you need to answer is what minerals are formed from crystallization of magma. The second type is precipitation. So precipitation has to occur during or near a body of water. It could be a lake, it could be a river. And what happens is as that water evaporates, it leaves behind a crystal structure, which is that mineral. And we'll go through some examples of that. Then another type is pressure and temperature. So when we have minerals that undergo pressure, they actually melt, and when they cool, they recombine to form a mineral. And the same thing with temperature. You could heat up a substance, and as it cools, it changes its composition and forms a mineral. And lastly, we have hydrothermal solutions. So hydro means water, and thermal means heat. So what can happen is you essentially have hot water flowing through a substance, and when that hot water leaves the substance, it causes the elements in that substance to crystallize and form a mineral. And we'll go through examples of those. Aha, okay, guess what? Here is an answer to your first question. So here we have 4 different types of minerals, and notice that they are a result of the crystallization of magma. So you want to write down one of these as the answer to my first question. And you probably saw at least 3 of these, I believe. I don't think I put hornblende in the classification of minerals lab, so I would write down one of these. Okay, here we go for minerals of precipitation. So this first one here is limestone. And you might have heard about limestone. We have plenty of deposits. It has to be near a water source, like I said, in order to have precipitation. This one, we definitely did, actually both of these we did in class. Okay, this is an example of halite. Don't ask me why my pen is doing what it's doing. I apologize. And this one, oh, this is calcite. And this is a shout out to Emily and Julia, who actually asked me, nobody else asked me, what mineral will react with hydrochloric acid. Calcite is one of them. So kudos to you ladies. Okay, here's minerals that are formed as a result of pressure and temperature. So on the left is talc. You may be familiar with talc. A lot of absorbent products will contain a powdered version of this. Not as many people use baby powder like they used to, but talc is typically used for its absorbent properties. And muscovite should look familiar because that was one of the minerals that you had to identify in your lab. So both of these are a result of increased pressure or temperature, and as the pressure is released or the temperature cools, these minerals are formed. Okay, and I think these last 2, I did not put these in your lab. So bornite and chalcopyrite, those both are formed with hot water. So the hot water moves through the substance, and as it leaves and cools, these minerals are a result of it. They're very beautiful. And when you think about it, what kind of property did they exhibit readily? And I'll give you a clue. It begins with a L. So hopefully you can think about that. Okay, here we go. Mineral groups. I've just got 5 more minutes with you and then I'm going to stop. So minerals are based on their composition. The first type is silicates. Now with silicates, you have to remember that we're looking for the presence of silicon and oxygen. So when I give you the chemical formula of the mineral, you're going to look for Si and you're going to look for oxygen. Let me write that again. So silicon and oxygen are going to tell you that you're in the presence of a silicate. And when you look at the actual formation of these minerals, it's based on their covalent bonds. If I have a chance in class, I will have you practice building silicate structures. Here we have Si in the middle, and we have 4 oxygens surrounding the silicon. Yeah, my tablet is not as responsive as I would like it to be. So a silicon tetrahedron, it actually gives you the structure of the mineral. Now, if you look at figure B, and my question for you, this is my second question. What type of mineral is this? Okay, so my first question was what mineral is produced with the precipitation or crystallization, I should say, of magma. The second question is what type of mineral is this? So go ahead and look in your textbook, or if you want to investigate silicon oxygen tetrahedron, tell me what type of mineral is that. So like I said, if we get a chance, we'll do this in class, but I'm not going to go into detail about that. Okay, the next group is carbonates. So with carbonates, what you're going to do is you're going to look for the presence of carbon and oxygen. So in the chemical formula, and we'll practice this, you're going to see carbon and oxygen. That's an O, not a triangle. I apologize. The other type is oxygen or oxides. Okay, now you got to be careful. You'll only see oxygen in the chemical formula. Okay, so that's different from carbonates. Carbonates, you have the presence of carbon. Here you just have oxygen. Okay, sulfates and sulfides. So sulfates and sulfides, you're looking for sulfur in the chemical formula. Sulfates is actually SO4. That's an O. SO4. So sulfur is a sulfide, sulfate, SO4 is sulfate. Halide, okay, halide, you have the presence of a halogen. So halogen, it could be chlorine, it could be bromine, it could be fluorine. And we'll practice this with the Socrative so you know what I'm talking about. Now lastly, we have native elements. So native elements are in their pure form. Okay, and I'm running out of time here. So pure form, we're talking about maybe silver, so Ag, copper, Cu, gold, Au, okay, so this is a summary of and the last question I have for you is give me an example of a halide. So the third question is give me an example of a halide.